Good morning, all the students. And now we are already going with our Newton's third law, laws of motion, very important law. Yeah, every action is a contained reaction with the same magnitude but opposite in the direction. That is only yesterday we already discussed. Yes, all the students, you have completed the yesterday's our homework or not? Completed or not? Akshay Sri and Renu Sri Gaur, Malleshwari, the remaining who are attended, please give your names. Shishank, Bhagavathi, Pavan Sai, or you are completed homework or not? Any doubt is there in the problems? You all are completed? Yeah, I hope you all are completed. Somewhat know why? If you have any doubt, please send the doubts to me. Okay, now about Atwood machine, it is a very important. Yes, for your higher classes also you have it here. Yes, and Atwood machine on friction in our higher classes. Just there is a extended concept. You take a friction force also. Here there is what we have taken in Atwood machine. There is a friction is not taken. Yes, friction is not take account. In case the friction is also take account, friction force is also taken account. Yes, how it will changes. That is only there in our higher classes, and sometimes an inclined path. In case you take an inclined path, how it will changes. First question. Okay, please send that whatever you not understood. Yes, please send to my WhatsApp number. Yes, now it is not time for the discussion. To this mobile number, please send this to this mobile number. Whatever you are not understood, otherwise you not get answer. Okay, now yes, you send to me. Voice is clear or not, all the students? Voice is clear or not? Yeah, there is somewhat not clear. Yes, students, yesterday we already discussed about our whatever Newton third law is there. Now we are going to discuss about Newton third law with the experimental manner, yes, of with the balloon rocket. Okay, and as well as there is what we are taking one more thing. How do we write the formula for our Newton third law? Simply here, the one body is taken as somewhat A, another body taken it is as B. Okay, clear or not, all the students? One body is taken as A, another body is taken as B. When you giving force on A, it is moves towards the B. It is moves towards the B, and B is also giving force on A. A is giving force on B, and B is also giving force on A. Clear or not, all the students? Now the force acting by A on B is taken as FAB. It is taken as FAB. Here there is a whatever force given on B by A, whatever force B is given on A, it is taken as FBA. Okay, clear or not all of you? Suppose I am taking this duster, and what the duster is giving force on this particular board. Okay, it is taken as A. It is taken as B. This is taken as B, and it is taken as A. Here both are giving force on one another or not? Yeah, it is taken as A. It is taken as B. Here A is giving force on B. B is also giving force on A. Yes, in this way, the force which is acting by A on B is taken as FAB. By B on A is taken as FBA. Okay, clear or not, all the students? At that time, the force FAB, yes, it is opposite, and it is written as FBA. FAB is equal to minus FBA. Okay, that is only called Newton's third law. That is only called what? Newton's third law. I hope you got it. Yes. When we applied a force F on force is called a Will force. But both are same in magnitude but opposite in the direction. Okay, this is only taken in the form of next formula, Newton third law formula. Okay, yes. And now next we are going to our experiment. One of the experiment is there. What is that? Balloon rocket. What is that? We have to take here balloon rocket. Simply so many times may you prepare this. Yeah, balloon rocket. Simply you take here one of the balloon, okay na, and for that balloon once inflate it, okay, balloon inflate it like this. You take a balloon, inflate it. Yeah, float it like this balloon. Okay, clear or not, all the students? Once you are here, okay, clear? Now, yeah, I am clear here the doubt. First, the reaction force every time is negative only. Okay, there is compulsory, we need not to write negative. But the negative is indicate what actually it is not a magnitude number. It is indicate only opposite to that. Everyone is getting like that only buffering. Everyone is like this only buffering. Just wait for 1 minute. Wait for 1 minute. Yeah, it is clear. Yes, there is a what we are taking here. This is the balloon rocket. Simply, you know very well. So, students, maybe it is a problem of not from my side. It is maybe problem from your side only. Your networks. In case any problem is there on that, it is appear on the screen. There is a screen. It is a very clear. Okay, here there is not a problem. Okay. Yeah, once check it out. This is only the balloon rocket. Once you take here, okay, once you take here, tight here, okay. Now there is a what when we remove here. When we remove here, automatically what is going on? It is going like this, like a rocket. Okay, once check it out. Okay, like that rocket it will be going on. Okay, yes, now why? Because it is occur. Why? Because it is occur. Yeah, when we are inflow the gas is enter into the balloon. The gas is enter into the balloon. There is whatever the here like this. There is we are taking here we take a balloon is like this. Okay. Yes, when we are sending the gas into this one from its mouth. Okay, now yes, it is entered and it is reaches to your middle. There is already the middle somewhat gas is there. The remaining gas particles are moved towards its walls. You know very well the gas is always what are moving in a random nature. The gas particles always moves into the random nature. Every particles are ready to move from its original places, and every particle is a giving force on the walls. Okay, clear or not all the students? Wall of the balloon. At the middle somewhat gas particles are there. Once you check it out, when you press it, it will be came out. When you press it, it will be also press on our. It will be press on my hand also. Here when you check here, okay, you take here chalk piece. Okay, now the chalk piece is what comes like this. Okay, clear or not all the students? Yes, chalk piece is the most like this or not? Once you check it here, yes, it will be what? It will be given pressure. Once check it out. Okay, clear or not all the students? When I am pressing, chalk piece is jumped like that. Clear or not all the students? When we are taking here, yes, moves like this or not? Okay, why it is possible? Because of my hand? No, my finger? No. It is given by the wall. Wherever you take, not only here, not only here, no, not only here. You take here, you take here, you take here. Wherever you take, at a walls, there is a what? What is that? Force is there. Clear or not all the students? There is a what? We are in time given action. There is a given reaction. There is given reaction. Clear or not all the students? Suppose I am taken here. The chalk piece is past moving. Okay, clear? Once check it out. Yes. Yeah, moving like this or not? Yes. Not only this particular place, wherever you go on the walls. What is there? The reaction of gas is there. On the where? On the balloon walls. When we press the gas, and it will be also press our particle. Okay now? Yes, and as well as that is the one thing. Another thing, when we remove this particular mouth, okay now, all the gases rushlessly come here downward. Okay now, that's why only our balloon is moves in a upward direction. Once check it out. Okay, it will be not appear to you, but it will be what moves in the particular direction. Clear or not all the students? Yes, I hope you got it. Yes? Once you check here, okay, now balloon is a moves now. Okay, clear? Like that it will be moves or not? Very rustly the balloon is a moves. Okay, now into the other direction. Okay, clear not all of you? Opposite to the direction of the gas. The gas is coming in this direction, balloon is moves in this direction. Otherwise, the gas is coming in this direction, the balloon is moves in the direction. Yes, that is only called actually balloon rocket. How to prepare the balloon rocket? Simply, you take a balloon and inflate it, and you take one straw and attach on the wall of a balloon. Okay, na? And once remove that whatever this particular mouth you remove from your finger, automatically that all our straw and balloon both are moving, okay na, into the direction. In a which direction? In a vertical direction. When we are making it in this direction. Clear or not, all the students? Yeah, it is only about what actually it is only about our Newton third law. What it says? Every action is a contain a reaction with the same magnitude but opposite in a direction. And moreover, that is about the rocket. But how it is possible? Because of this diagram, whatever shown here. Okay, all the gas which is enter into the balloon, they giving force on the valve. Okay, they are ready to move. You know very well why it is occur. The gases are contain a random motion. Gas particles are contain random motion. The randomly they contact with these walls, okay, and this wall is also giving force on that a particular particle. They move again into the another direction. Like that it is going on. Already we are discussing. When you press by the chalk piece is a came out. Okay, clear or not, all of you? Yes. When you press it, that all the gas whatever there in the balloon, they are also pressing our chalk piece through the layer of the balloon. Okay, clear? This is only the action is contain the reaction. That is only proof is given by our balloon rocket. Got it? Yes. This is only the information about the Newton third law. Any students, any doubts are there here about the Newton third law? Yeah, one more lab activity is also there. What is the lab activity there here? You have to show the action and reaction force acting on two different objects. Okay, clear or not, all the students? We have to go with the lab activity now. Yes, what is the lab activity? Yes, the lab activity main aim is we have to show yes, the action and reaction of force acting on two different objects. Okay, clear or not, all the students? And now we are taking here one more thing. What is it? Materials are required. Materials are required. What for us here? What the materials are required for it? Test tube is required. One test tube you have to take here in this manner. You have to take one test tube. And another there is what we are taking. One stand we have to take here. One stand we have to take here. Here we take a stand like this. Okay, and moreover, you have to take here rubber cork. Yes, we have to take rubber cork here. Before add to the rubber cork, we have to take here what actually? Yes, in this one you have to take here. Water inside it. Before that only you take water, and here you take a rubber cork. Like this rubber cork you take here. Got it? And now there is a what we have take here on this particular stand. Okay, clear or not all the students? On this particular stand, you have to take here. Yes, one burner you have to take here. You take a burner. You take a burner and you take a first stand, you take a 2 threads. You take 2 threads here. Got it or not all the students? This is only the simple experiment we have to go for here. Here we are heated this automatically whatever the substance contain inside this test tube, that is water. You know very well. Water is become vaporized. When it is vaporized, yes, it will be moves like this towards what? This rubber car. Clear or not all the students? Yes, it will be moves like this rubber car till heated. You are heated like that. Okay, now after some particular time, whatever the heated gas is there, the rubber car came out because of the pressure of this vapor. And at the same time, the test tube is opposite to the rubber car direction, it will be moves. Okay, this is only about our lab activity. The simple lab activities are given for us for the finding that this action is equal to reaction minus reaction. Here what we are given, there is simply you have to take here one stand and test tube and water, rubber car, one burner. Okay now. All the students, please don't discuss any other matters in our class. We discuss later whatever the things are there. Okay, and here when you take here that file, that because of the file, whatever the water components are there, the water are heated. Here water is heated, and the heated water is converted as a vapor here. It is converted as a vapor. You know very well. The vapor is one of the hot gas. It is a water gas actually. The gas is pressing this rubber car. Okay, now still we are heated. The rubber car came out from this whatever test tube in this particular direction. At the same time, okay, now whatever our suspected test tube is there, it will be opposite to the direction of this forward one. It will be returned back. Understood all of you? Yes, this is the action. This is the what? This is the action. This is become what? Reaction. This is become reaction. Okay now? Yes, in this way we have proved our Newton third law. In this way we have proved our Newton third law. Yes, based on our conclusion, whatever we have taken. Every action is a contained reaction in a two objects. Here we have taken two objects. What is the two objects? One is the test tube, another one is the rubber car. There is a whatever the test tube material is there, that is pressing the rubber cap in the front. At the same time, wherever it will be came, that will be returned back. You know very well. So many things are there like that. When you take a gun, machine guns. Okay now? Yes, we not have that machine guns with you, but when you are observed in a movie, when there is a gun is working at that time, every time, for every bullet it will be back. Okay, there is a bullet is a move front. Clear or not all the students? Yes, when you are taking the firing, when you start the firing, okay, now at that time the gun is under that it is attached with our body. And automatically it moves front. Got it or not all the students? Yes, there is also Newton's third law is also same like this. Okay, so many observations are there. Swimming, okay now, our fish are ourselves also. When we swim, we are taking the water back, we are move the front. Okay now, like that number of examples are available for us. Okay, clear or not all the students? This is only about our Newton's third law. There is a given somewhat think and discuss questions in this our based on Newton's third law once we go for it. Okay, Mr. Nani, what you are typing? Here in the page number 42. Page number 42, we have the one of the think and some think and discuss questions. Once go for it. Yeah, there is once take it out in this one, the force exerted by the earth on the ball is 8 newtons. What is the force on the earth by the ball? Okay, clear or not? All the simple thing only. Here there is a what is a given, the force exerted by earth on the ball is 8 newtons. What is the force on the earth by the ball? It is also 8 newtons only. Okay, now, but we have taken 8 newtons of what it is, the earth we have taken. Okay, on this one ball is giving one ball is yes, bump on the earth automatically with the 8 newtons. It is also giving yes 8 newtons force on the surface of earth. In this direction 8 newtons means what? In this direction also 8 newtons only. Okay, clear or not all the students? And now, but the direction is a difference, that is opposite to that. And next come to here, a black placed on horizontally on the surface. There are the two forces acting on the black. One is the downward pull of gravity and other is the normal force acting on it. Are these forces are equal and opposite? Yes, do they form action reaction pair? Discuss with your friends. Okay, simply you know very well. Yes, when you take a here like this, suppose I am taken duster and this book, the same, whatever think and discuss concept is same as like that. Yes, when you take here like this, there is a duster is a giving force on, normal force on it or not, book, and as well as there is one more force also working on it. What is that? What is that? Gravitational force is also working on it. Okay, whatever the normal force is given by it. Yes, and here that is equal to the which one? That is equal to the our normal force. Okay, these two are the what? These two are also for reaction and action pairs only. Got it? This is only the information about our next concept of a think and discuss. Got it? All the students got it or not? I hope got it here. Are these forces are equal and opposite? Yes, these forces are equal and opposite only. Okay, these two forces are equal and opposite only. They form a action and reaction pair. Yes, they form a reaction and action pair. Okay, now yes. Next come to here. Last thing and discuss in this one. There is a what is a difficulty for a firefighter to hold a hose that ejects large amount of water at a high speed. Okay, clear or not all the students? Yes, why it is a difficulty to firefighter to hold a hose that ejects a large amount of water at high speed? You know very well. Yes, firefighters are taken somewhat water. It is a what? They taken the what? Very heavy like the things are there. Okay, they taken like this. Okay, now every time they are handled with a high force. Why? Because there is very small nozzle is there. The water is coming with high pressure. Okay, like a balloon. Similarly, like a balloon. At that time, there is a what? When the water pressure is first acting on where? On the nozzle of pipe. First nozzle of the pipe. There is a high force working on it. Automatically, that force is okay now. Yes, we are take like this every time. Every time that whatever pressure working on the nozzle of the pipe which is taken for the firefighter, okay, now that will be giving a reaction force backward. Okay, why? Because there is a high amount of water is giving pressure on the nozzle. Okay, now because of that nozzle is makes what? It will be makes the back. Okay, in this way handling the pipe is a very difficult. Okay, clear or not all the students? Once imagine, otherwise once show any of video of firefighters how they are handling that pipe. Okay, clear or not all the students? Otherwise, when you take a pipe in our home also, okay, the water pipe, when you take here the finger at here, automatically the water is giving force on the nozzle or not? It will be go somewhat. Handle of that things is a very difficult. It's in a small pipe. In that 5 pipe purpose, they are using the what big pipes. That is a contain. Yes, at this particular place is like this here. Okay, clear or not all the students? Here there is a what we have small nozzle is there. Okay, clear or not all of you? Whatever the water may come from here. Okay, clear. There is a giving high pressure on this particular area. You know very well. Force on area is only called pressure. Yes, it will be giving move. It want to move in this direction, but there is a whatever the water is there, they moves opposite to this particular point. There is a action is there, and as well as the reaction is also there. Okay. Yes, everywhere there is a force is contain action is equal to the reaction. That is only the think and discuss concepts. All the students, you will compulsory write this think and discuss concept in your classwork notes. Yes, classwork notes. And next thing, conservation of momentum. Conservation of momentum law and as well as the impulse. Okay, clear not all the students? Next concept is the conservation of momentum and as well as the impulse. Clear or not all the students? There is a next one is conservation of momentum. All the students, what is the conservation? What is the conservation? What is the conservation? How to solve this conservation of momentum? Already in your 7th class, already we have discussed. Yes? What is the conservation? I am not asking about the momentum. What is the conservation? Conservation means remains constant or remains same. You know very well conservation of energy only. In your 6th class only you have completed about conservation of energy principle in the lesson of heat and measurement. Okay now, conservation of energy means what actually tell me? Conservation of energy means energy is not created by us, energy is not destroyed by us. Okay, but energy changes from one form to the another form. But total energy of the our earth remains constant. Clear or not all the students? Not it is. Conservation means constant, remains constant. Okay, clear not all of you? It is not destroyed by us, it is not created by us. Which one? Energy. I am given for energy. Yes, but energy is changes from one form to the another form. But total energy of universe remains constant. That is only called the conservation of energy. Got it or not? Yeah, water is conserved. Okay, now in a water cycle you know very well conserved. Water is conserved. Why? How the water is conserved, tell me? Yeah, there is a whatever the water sources are there, that is heated and by evaporation process they converted as a vapor, and the vapor is a cool down because of condensation and they become as a clouds, and the clouds again, yes, one clouds are become what? Heavy with the water drops, and automatically the water drops are made divided from that clouds again they coming in the form of rain, and again they reaches to the where there is a water sources, and again the evaporation, again the condensation, like this. In the water cycle what we are observed? The water is conserved. Yes, here the momentum is also like that only. Our momentum is also conserved only. Okay, clear or not all of you? Why? Because once there is a velocity that created that may not losses. Okay, now that is may changes into the another form. May there is a velocity once generated. Okay, now otherwise that it is in a rest. Okay, now that is not a conserved. It is sorry, it is a conserved only. That is when you are created one velocity, it is a collide with another body. It's a transferred whatever the force is there. Okay, whatever the velocity is there to the other body. Okay, clear or not all the students? Suppose there is a what we have taken. Bullet is hit one wooden plank. It will be collapses. Okay, clear or not all of you? Once imagine your mind. The very fast bullet is coming and it is collide with the watermelon. What will be going on? The total watermelon is blasted. Okay, clear or not all of you? What the principle is there here? That is only conservation of momentum. What is going on? There is whatever the speed of the bullet is there, whatever the velocity is there for the bullet. Okay, at that time it is contains somewhat of force, somewhat energy. That is transferred to which one? That is transferred to that watermelon. Clear or not all the students? That is only the okay. Clear or not all the students? That is here the bullet velocity is losses. No, it is not losses. It is changes into which one? Changes into our watermelon. Okay, clear or not all the students? This is only called conservation. Okay, here simply when you take our conservation of momentum law. Okay, now. Yes, there is you take one body of mass m1, another body of mass m2. Okay, now you take it is a mass m1 is moving with the velocity initially with u1. Another body velocity is taken as u2. Okay, clear or not all the students? And what is the momentum of m1? What is the momentum of m1? Now the momentum of m1 body is taken as m1 u1. What is the momentum of m2? There is the momentum of the body is taken as m2 u2. Okay, clear or not all of you? Now we imagine that there is these two m1 and m2 are one is a collide with another one. One is a collide with another one. One is a bombarded with another one. Okay, clear or not all of you? And automatically, yes, after this collision, our m1 body may reaches with the v1 velocity. Our body is traveled with the v1 velocity. And as well as m2 is moves with the velocity of v2. Velocities are changes here because of the collision. Yes, in this conservation of momentum law, there is a whatever the velocity changes are there with the masses are conserved or not. We have to prove yes whatever the velocities are changes in the masses are conserved or not. That is only we have to prove in a conservation of conservation of momentum law. For this purpose, we have to take here what? We have to take here. Yes, we have to take here. We have to take here our Newton third law. Okay, by using Newton third law only we have to prove our conservation of momentum law. When there is no external force acting on the body, there is a momentums of the bodies are remains constant. The exact statement of the conservation of momentum is what you know. There is an external force acting on the body is zero. Okay, now the momentum of the body remains constant. That is only conservation of momentum law. All the students, yes, the time completed and no time for explanation of total conservation of momentum law. And tomorrow is tomorrow and after tomorrow and Sunday no classes of my classes are not there for me to that's why only we go with our next class of this conservation of momentum law. And happy Children's Day advanced students, and I will happy Diwali to you all. Okay, bye, take care.